Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss how to predict for new data in support vector machines. Support vector machine performs a classification based on the concept of decision planes that define the hyperboundaries, also known as hyperplane. A decision plane is one that separates between a set of objects having a different class membership. The objective of the hyperplane is to maximize the margin between the two classes. The vectors that are used for classification are known as hyperplane. A support vector machine is a supervised machine learning algorithm that can be employed for both classification and regression purposes. Support vector machine is highly preferred by many as it produces a significant accuracy with less computation power. Support vector machine can be used for both regression and classification technique, but it is widely used in classification objectives. Now you can see here there are 2 points, two groups, one shown in circle and another shown in cross. Those points which are nearer to each other in two groups forms the support vector. The objective of the support vector is to increase the distance between them, which is known as margin, and the plane which segregates, which differentiate between these two groups is known as hyperplane. Now let us see how we can do this in Rapidminer. So we want to test the new data set in Rapidminer. So first of all, we will have to train the model. So for that, I'll load the data set Heart1. I'll connect the spline here and run the play button. You can see here the attributes which have been considered here for the prediction of the heart disease are age, gender, chest pain type, resting blood pressure, cholesterol, fasting blood sugar, resting ECG, max HR, exercise, old peak, ST slow, and the heart disease. Basically, on the basis of these attributes, we want to classify a person's heart disease. That what are the factors which contribute to the person's heart disease. So again, we will go in design, and here we will select the attributes. Now it is not necessary that in your data set all the attributes are matter of my interest. So I'll select this operator. I'll go in subsetting it, select the attributes, and this time I'll select the attributes like age, cholesterol, fasting BS, heart disease, old peak, resting blood pressure. Apply. Now I will activate the set role operator. Basically, the support vector machine falls under the supervised learning technique, which means that we'll have to specify the dependent variable. So I'll go here, activate the heart disease, and make sure that the target role is specified as label. Now I will go in cross validation. I'll activate the cross validation here and simply I'll drop it here. Disconnect this spline. Now when any operator is having two layers, it means that there is a sub process which is running. So when I double click, I'll be entering into the training and testing data set. You can see here it is a training and testing data set. So now I activate SVM from here, support vector. I'll simply drop it, connect training to training, model to model, estimated to true. Now I'll go and apply the model. I'll simply drag it and drop it this model to model, test to unlabeled, and now I'll select performance operator from here. Activate the performance operator which is related to the classification. Connect label to label, performance to performance, example to test. When all the connections are over, press up arrow and you will come in the main process. After this is being done, you will have to connect, apply model. Activate apply model again. Drop it here. Now pass this model to model. Now here, our objective is to predict for new data. So I'll select hard test from here. Now this is a completely new data set. This data set, the test data was never seen by the model. And we are feeding this new data to the model, this model. Again, the pre-process of select attributes and set rule has to be done. This can be done. Press Control button, right click, copy, Control V, bring it here, connect this spline here, and it is being done. Now pass this example into the unlabeled. Now connect this label to result, model to result, and press the play button. The results are ready. But you will have to directly go in example set. This is the testing data. Now the prediction has been done by the algorithm. For the heart disease, this is a prediction which has been done. And this is the actual data. Now you can see here the prediction has been done for the first patient. The heart disease was not there, and actually the heart disease was not there. Similarly, here the heart disease was not there, but it was present. So the prediction is there, the confidence is there, and here you can get the confidence also. This is a way you can predict new data in Rapidminer. For more videos on Rapidminer, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Kindly refer my playlist in which I have already uploaded many videos of Rapidminer. Please don't forget to press the like button. Thank you.